In the next set of examples, what we're going to do is we're going to show you some more quick examples of how we can use these transformations to help move the graphs around. We're going to use as a basis the sketch of the graph of f of x equals 4 to the x, and that's the red graph here. This is the sketch of the graph y equals, or f of x equals 4 to the x, so you can quickly check that. 4 to the first power is 4, so that's the ordered pair 1, 0. If you put in a negative 1, that's 4 to the negative 1, which it should be 1/4. So that's here. And then also 4 to the 0 is 1. So that's our red graph. All we're going to do is we're going to do our transformation to help us draw a new graph. So to do that, I'm going to trace right over this one. And then I can move that graph wherever I want. So the only thing that we need to do this graph is we can notice by the equation that we have a vertical transformation. The vertical transformation says move this graph 2 units downward. There are two things that are really nice whenever you're dealing with exponential graphs. Number one, take that vertical or horizontal asymptote, and first thing you want to do is move it 2 units down. So we want to move it down to a -2. Next thing I want to do is I want to grab the other good point to graph is this point right here. It's something most of these graphs, or almost all these graphs, have in common, because anything raised to 0 power is 1. So that's why that number or point seems to be there. So we're always going to move this down. If I'm at a positive 1 and move it down 2 units, then it's going to go down to a -1. So this positive 1 goes down to -1. Bam, got our graph, we're done. So that's the transformation that we did in question A. Now, in question B, we'll clear that off. We'll start again. Question B, just to show you that I wasn't lying, it didn't cheat too much. That's what that graph would look like. You can see that the positive 1 goes down to a -1. You can see that the horizontal asymptote at 0 is now down here at a -2. Simple deal to do. Don't forget your transformations. Very, very powerful tools in curve sketching. Okay, in the next graph, we have some different transformations that we have to take care of. One of the transformations that you see there is you put a negative in front of your function. Now all that does, remember, if we put a negative in front, it's going to flip it about the x-axis. So this is like the transformation where you put in a negative of your function. So our function is f of x equals 4 to the x. So what is, if we put in, I guess m at x is how they're naming it, a -4 to the x. All this does, it takes our graph that's going as an increasing curve, it's going to flip it about the y-axis, and now it's going to become a decreasing curve. So that's kind of what that part does to it. But what does this other part do to it? Exponents, kind of a tricky deal. When you see that, this is really 4 raised to, it's the x plus 2. So there's an implied grouping symbol up there that's saying that is your exponent. Treat that as a single number. So as you think through when we did these transformations back in our first unit or so, whenever it was in parentheses, it was going to be a horizontal shift. So this is going to move our graph horizontally. And these horizontals are always counterintuitive. So if it says x plus 2, it doesn't really move it right 2, it moves it left 2. So okay, let's take our graph and let's do those two things. And I'm also going to get a little bit more fancy here. That wasn't very good. Let me try sketching that again. Should be able to trace. I guess I should have gotten better marks and coloring when my grandma was teaching me how to color. I distinctly remember her trying to do better. Alright, and the other thing I was going to do is put this in there. We'll get it a little more distinctive color so that we can see it better. And I like, what color do I like? I like blue today, so we're moving that to a blue. This represents our horizontal asymptote. Okay. So here's what we need. We need to do 2 transformations. We need to flip it about the x-axis, and we also need to move it 2 units to the left. Now what order should they go in? I guess technically what we should do is go in the order of operations. What would happen first if you tried to evaluate these? And if you try to evaluate this expression, the first thing you have to do, according to your order of operations, you have to perform your exponent stuff first. So the first thing we're going to do is we're going to shift this graph 2 units to the left. Let's take our point here. This is our nice tracker point. We want to go 2 units to the left. So that's going to go over to a negative, come on back, -2. So that means the graph gets shifted over here. Next thing that we got to get it to do, we got to get it to flip or reflect across the x-axis. Now this is something I don't think I can get this program to do, so I got to do this by hand. If I reflect this point, this ordered pair -2, 1 becomes -2, -1. These other ordered pairs that we had, I suppose I should have tracked those. This is the ordered pair 1, and we had a 4. So the ordered pair 1, 4, when we slid it over 2 units to the left, it became a -1, 4. So now when we reflect across the x-axis, it becomes a -1, -4. and that's probably enough. I could get that one other point up there and help, but I'm going to go right towards that horizontal asymptote. So that's what that graph should look like. Again, I had another graph of this so we could see what it looks like from a graphing calculator perspective, or from the computer. If we go down far enough, our next point is going to be negative 16. I tried to show that because if you put in a 2, 4 raised to the second power is 16. So our parent graph of 4 to the x is 16. If we slide it 2 units to the left, we'll be right over here on the x-axis, or I'm sorry, the y-axis. Then we've got to reflect it down. So this ordered pair, which is 2, 16, slid over 2 units because of the horizontal translation, becomes 0, 16, and then reflected across the y-axis becomes 0, negative 16. So trying to give you some evidence there of what's going on with these transformations on these graphs. So I'm going to put this one back in the way. And we'll go to our last transformation. The last transformation that we're asked to do is 2 times 4 to the negative x. So we've dealt with this negative x before. Here's the second time, so we've got 2 different transformations. Number 1, we've got that negative x. That's going to be a reflection across the y-axis. And then we have that 2. Whenever you multiply by 2, that's going to be a vertical stretch. So we've got 2 things going on, reflection across the y-axis and a vertical stretch. So if we take our original graph, which is here, okay, and we do the reflection across the y-axis, and I can track this for you also numerically, so we'll give you some ordered pair evidence. We're going to look at this being 4 to the x is our parent function, so if I put in a negative 1, that gives us back a 1/4. If I put in a 0, it gives us 1. If I put in a 1, it gives us a 4. Okay, so now the negative x means we're going to reflect it across the y-axis. So if we reflect across the y-axis, then the ordered pair is going to be a negative 1 instead of being a negative 1 positive fourth. We reflect that negative 1 positive fourth, it's going to become a positive 1 1/4. So it's going to, it's harder for me to draw this, but it's going to become the ordered pair 1 1/4. We reflect the ordered pair 0 1, it's still at 0 1. We reflect the ordered pair 1 4, that's the ordered pair 1 4 that we're reflecting across the y. It becomes a negative 1 4. So there's our reflection across the y-axis. The other transformation we're supposed to do, and I'll just put this as the reflection, the y-axis. The other thing that we have to do is we have to take this thing and we have to double the output. So we have to take everything times 2. So if we take all of the y values times 2, remember that's just the outputs, it's a vertical stretch. We're going to act on the vertical components of our ordered pair. So it's going to be the ordered pair 1 comma, you take 1/4 of 2, 1/4 of 2 is half. You take a half, or you double the 1, it becomes ordered pair 0 2. If you double the 4, it becomes negative 1 8. So these are the final ordered pairs that we have to graph, rather than trying to flip this, which I can't do on this board. So we got 1 and then a half, so we'll go up 1 and a half, plot that point, go to 0 2, there's that point, and we go to negative 1 8, which is going to go way off my graph here, but just try to replicate where that would be. There's got to be somewhere up in there. So here comes our graph. Okay, so thinking through those, we have 2 things, vertical stretching, and we also have a reflection across the y-axis. And just to kind of show you that this should match up pretty well with this other graph that I have. And you can see that the one that we have, the red one is the original graph. The other graph, that's my green graph here, is the black graph on the computer graph, and that's matching up pretty well. Okay, so like I said, we want to be able to use our transformations to draw sketches. This again will be a portion of your test that you'll have to do without assistance of technology. So practice it that way so that you're ready for it.